Well, thanks, Richard, and thanks everybody for being here. Thanks to the organizers also for putting this together. I do think that we live in a really unique point in time as researchers at the intersection of AI and education. In fact, the whole thesis of my talk is that if there's ever going to be a decade where AI really changes education, we're living in it right now. Of course, whether or not that happens depends on all of you, but it's really a unique time. Here's my logic. It's simple. Fits on one slide. First of all, we've known for a long time, decades, that one-on-one human tutoring dramatically improves education outcomes. Bloom in 1984 told us that we could get a 2 sigma improvement in educational outcomes by having one-on-one human tutors, not computer tutors, so that tutored students would outscore students in a normal classroom 95% of the time. But of course, we don't have enough teachers to assign a dedicated individual to each student, although we do have enough computer programs. Number two, we're at a point in history where we finally do have a number of systems, including Squirrel AI, Carnegie Learning, CK12, that have taught literally millions of students. And so these systems have more teaching experience than any human teacher could get in a lifetime of teaching. As machine learning people, we ought to be able to do something with that. And then the third part of my argument is it just happens that in 2023, progress in AI is ridiculous and accelerating. So I think this decade, all these things come together to make a kind of fertile ground for research and deployment of AI for education in a way that we've never really had before. So it's great to be working in this field right now. It seems to me there are 3 particular AI technologies that are going to drive the development of education tools for this decade: machine learning, natural language, and multimodal speech, video, etc. perception. And there are different educational settings where this is going to happen. There will be student computer homework sessions, for example. There will be student-teacher computer sessions with teachers around, and there will be teams of students working with computers. I know that Sydney leads, who's giving the next talk, leads an NSF center that's focusing very much on student team learning. So I'm going to focus more on the earlier settings, but hopefully between the 2 talks, we'll cover a lot of ground here. Okay, so let's get started. What can machine learning do to change the game? I'll take as an example CK12. CK12.org, you can go there, but don't go until after this talk, is a free open website where, without a paywall, you can go and take a variety of courses in science, math, social studies, language, etc. They've been in business long enough that they now have over 200 million student logs. That's a lot of data. That adds up to 40 million hours of student learning on their platform. My wife asked me how many years was 40 million hours, and I didn't know. So I did the arithmetic. How many years do you think 40 million hours is? It's 45 centuries. That's a lot of student hours of learning, more than any single teacher could observe in a lifetime of teaching. So just think about that as the raw material that we as AI researchers get to work with. Okay, so what can we do with this? Well, there are 2 things primarily that we want to do with this data. Number one, we want to learn how to assess what students know at any given point as they go through the curriculum, student assessment. And number two, we want to learn how to choose the most useful teaching action. So those are the two key machine learning problems, actually. So let's take a look at these. First, what does that data look like? Here's some of it from Squirrel AI. This is one session of one student out of a 60 million line log file that shows a 1 3/4 hour lesson of a student. And this student comes in first, does a pre-test. Each of these lines describes a particular question, whether they got it right or wrong, how long they spent on it. Then the student watches a video here. Then they solve some practice questions. Then they study the solutions to those questions. They're shown another video, but they don't watch it all the way through. They skip out in the middle. They solve some practice problems. Finally, they have a post-test, and then they review their performance on that. So this is the kind of log data that we get for each of those students going through these online courses. And as I said, there are two things we primarily want to learn from this data: how to assess new students coming through by learning from the trajectories of these earlier students, and learning how to choose the right teaching action. So let's look at the first of these. Here, I think of this as really the diagnosis of the student state problem. And this is what the competition in this workshop is all around. So I'm sure many of you are actively working on this problem, which of course is to estimate which concepts the student does and doesn't understand at any given time as they go through the course. Now, in the most common way of having a computer represent student knowledge state is to represent it as a vector of probabilities, where the ith element in that vector is the probability that this student would answer correctly if we asked question I right now. And now many of these courses have thousands of questions. Typical courses have thousands of questions. And of course, no student gets asked 1,000 questions. But if we have millions of students taking the course, each of those thousands of questions is going to be asked at some point in time of some student. And we will have some training data that, for example, might show that this question number 67, students who have gotten the right answer to question 43 and watched video 4 afterwards, 90% of the time get the correct answer to this question. So we'll be able to discover those kind of irregularities. And so the machine learning task is to learn a function where the output is the probability of being correct on that question at that time. And the input, this will be a function of the student history up to that time, plus some static feature of the student, like what grade are they in, and the question at hand. Okay, so much of this workshop is around this problem. I refer you to the upcoming talks. I'll just give one slide to show a quick summary of the state of the art. So this is based on a study that Robin Schmucker, who's sitting right here, performed and wrote up last year, in which he took 4 different educational data sets, including that Squirrel AI one, which had 60 million lines of log data, but also 3 other data sets that had tens of millions of lines of log data. And he trained machine learning algorithms for this knowledge tracing problem. And how well does it work? What's a typical way to think about the state of the art? Here's the way I think of it. The trained models, when cross-validated and tested, had an AUC score of around 0.8 across these 4 different data sets. How should we think of that? Well, it turns out the AU C-score, one nice way to think of it is this. Once we train the model, then if we have a new student and we show the model the history of this student so far, and we take two new questions which we're about to ask the student, and the student answers one of those correctly and answers one incorrectly, then the AU score is basically what's the correctness rate of the model in figuring out which of these two questions the student's going to get correct versus incorrect. So in other words, if we give it a random pair of correct and incorrect answered questions that it hasn't seen yet for the student whose history it has seen, how often will it be able to tell us which of those the student answers correctly versus incorrectly? So what this number means then is that 80% of the time, 4 times out of 5, these algorithms, this is roughly the current state of the art, 4 out of 5 times they can tell us which of those two questions the student will get right or wrong. Now, this research continues. It's going to get better because of people like you all. But some of the ideas that are in this approach that lead to the current state are, number one, although early approaches looked only at the sequence of questions that the student had been asked and answered before, we now see that if we use a richer description of the history of the student, we can get more accurate predictions. So we want to look not just at the questions answered, but the text read, videos watched, how long they spent on that, the time that it took to answer different questions, and so forth. It turns out these are all relevant features that the machine learning algorithm can use to improve its accuracy. Number two, we want to incorporate prior knowledge about which questions map to which topics, or some people call them knowledge components, some people call them concepts. But for example, question 5 might be a question, how much is 5 plus 7? That's about the topic of single-digit addition. And we can tell the system that question 7 and question 9 are both about the topic of single-digit addition. Then this helps in student assessment, because when we're trying to predict how well the student will do on question 7, we can look at that student's historical performance on other questions related to the same topic. Similarly, we want to look at the prerequisite structure. If we want to know how well a student will perform at 9 times 7, we might want to look at the prerequisite of addition. Usually you have to be able to add before you can really understand multiplication. And so if we tell the system, this is the prerequisite structure, addition is a prerequisite for multiplication, then again, our algorithms can use that background information as a kind of inductive bias for learning, and for also use it for synthesizing features like what's the correctness rate historically for this student on this topic. So those are some of the things that that fit into the current state of the art. But as I mentioned, we should all just come and listen to the talks later on today to get the real state of the art. Okay, the second question that I said we want to deal with is how to choose best teaching actions. And so here, the machine learning task is to learn a function that produces the right teaching action out of a list of candidates as a function of, again, the history of the student up to time t, and static features of the student, and the decision point we're at in the class. Let me give you an example. And this one comes from CK12. And this is a study that, again, Robin Schmucker, still sitting in the same place, drove, where we looked at the question of what teaching action should we provide to the student. We looked at the specific case of which hint should we give to a student if they answer a question incorrectly, and we're going to give them a second chance. But before their second chance, we're going to show them a hint. And can we learn which hints are most effective? So here's an example. Here's a question. Integral monotype proteins are permanently attached to the membrane from the cytoplasm, one side, both sides, the middle of the membrane. Multiple choice. If a student gets that question wrong, here are 4 things we can show them. Hint 1, the prefix mono means single or alone. Hint 2, the word integral means essential or necessary to make whole. Hint 3 is an entire paragraph. You can read it, I won't. Hint 4 is actually vocabulary, defining some terms, cytoplasm and protein. Now, which of these hints is going to work best? Nobody really knows. Teaching is like this. We can make up, trust me, I've been a teacher for many years. We can make up what we think will be helpful, but it's actually an empirical question. What works best? And the great thing is, in 142 days of time, we were able to collect data about over 1,000 of these biological questions, where there were 7,000 candidate hints, typically 5 or so hints per question. And we collected 3 million student hint pairs that were experienced, and we could look at the outcomes. Now, what's the outcome we're interested in? Well, it'd be nice for the student to get the question answered correctly when they tried again, but that's really not all, because that would make a hint like the answer is C look like a really effective hint. So in fact, what we want is, and what we ended up doing was defining a reward that is a blend of the correctness rate on the second attempt and the final student ability measured by their IRT score, standard kind of grading score at the end of the lesson. So using that as our reward function, it turns out, I can tell you, hint number 1 is the winner. Hint number 1 actually works better than these other hints. Here's some details about the different choices of teaching actions. And you can see in this 140 days, we were able to collect almost 1,000 examples for each hint question pair in this case. So we have plenty of data to get statistically significant evidence of things like which one leads to the best score measured this way, and which one leads to the better, say, completion rate and so forth. Okay, the take-home message is simple. With today's data and today's machine learning algorithms, we already can significantly improve our ability to assess students automatically as they go through the course and identify empirically what are the most successful teaching actions, provided we're willing to write down a definition of what we mean by successful. Okay, so that's part 1. Now think about this. This is what we can do with machine learning and the volume of data, but that's just one aspect of AI. As I mentioned, I think there's several threads of AI progress that are going to be important for this decade. Natural language is clearly one, and of course, you can't talk about natural language without talking about ChatGPT. So as I was preparing this talk, I did some experiments with ChatGPT. First, I asked it some questions. I went to, again, a CK-12 biology course, and one of those thousands of questions was this one. Asexual reproduction presents both advantages and disadvantages. What is a disadvantage of asexual reproduction? That's one of the questions in CK-12. It's a multiple choice question. I asked it just this way. Here's GPT's answer, which is actually a correct answer. A disadvantage is that it does not allow for genetic diversity. It goes on to explain the details. Interesting. So ChatGPT knows some factual knowledge already. Then I decided to ask it, if a student answered that question by instead saying that the disadvantage was that reproduction was too fast, that's one of the multiple choice answers that some students choose. What hint should we give the student to help them? Here's its answer. The important thing here is the bottom. A hint that could help the student understand the concept better would be to ask them to think about how asexual reproduction affects the genetic variation of the population. Ask them to consider how that lack of genetic variation could make the population more vulnerable to environmental changes and how it could affect adaptation and evolution of the population. That's a good hint. Okay, so at least in some cases, we can ask ChatGPT to generate hints. What about other cases? So I asked a math word question, simple one. Suppose I buy 2 boxes of eggs and each box contains 12 eggs. I open one and eat 2 of the eggs for breakfast. How many eggs remain? Its answer was correct. Therefore, in total, you have 22 eggs. So then I said, if a student could not answer that question, what hint should we give them? And here's the relevant part. Think about how many eggs are left in each box and how many you have eaten. This should help the student focus on the key information. You can decide for yourself whether you like that hint or not, but it's not totally off the mark. It's not a crazy thing to say to the student. Okay, so then, encouraged by this, I went forward and I thought, in some cases, engagement of the student can be influenced if you can reword problems to their interests. So I gave another word math problem about eggs. Sorry, this is a slightly different example. In this case, I bought 2 eggs, 2 boxes, and I gave away 3 eggs from each box. But then I said, and it solved that question too. Then I said, rewrite this math word problem so that it has a sports-oriented theme. Here's what it came up with. The basketball team collected 24 basketballs for their training session. Each day before the training session, they gave away 3 basketballs to a local youth basketball team. After 2 days, how many basketballs remain? That's pretty good. Okay, so in this case, it's able to take the word problem that tests the concept I'm interested in. I give it a new topic. It was able to rephrase that to make it of interest to somebody who has maybe a basketball interest. So then I kind of went crazy. How about amusement park theme? How about a birthday party theme? How about, most importantly, a Pittsburgh Steelers football theme? And each of these is totally reasonable, right? Pittsburgh Steelers collected a total of 24 footballs for their training season, but each day before the training session, they give away 3 footballs to local schools. After 2 days, how many footballs does the team have left for the training session? It's a good rephrase. And just for completeness, I asked, well, what's the hint we should give if they couldn't answer the Steelers question? And again, a good hint. Okay, so ChatGPT knows some factual knowledge. It can generate hints. It can solve some simple math word problems. By the way, not all of them. I tried some like Mary went from point A to point B at 60 miles an hour at the same time that Joe went from B to A at 30 miles an hour. Where did they meet? And it said in the middle. Then when I asked some more follow-on questions to make it recognize its errors, it just got confused. So it's not perfect, but in many of these cases, in these online curricula, we do have questions and we know the answers. That's because we're going to see if the student answers them. So One strategy might be ask the question GPT. If it gives the right answer, then you might go forward and consider it possibly generating hints. If it gives the wrong answer, just move on. And of course, this is only 2023. We still have 7 years left in this decade before we get to 2030. Okay, so then I moved on. What if I give it a lesson to read and ask it about that? So here's a lesson again from CK12. This one's about the nucleus. Here's the text. I turned that into the following prompt. I said, please read the following text, then write some questions that would test the student's understanding of the text. And then I concatenated, I just scraped this text. So where does DNA live, et cetera, is just the text that was here. So basically, I asked it to consider this text and write some questions. Its response, these questions. What is the main difference between prokaryotic and eukaryotic cells? What's the largest organelle in the cell and where is it located? What's the role of the nucleus? How is DNA organized in the nucleus, etc.? These are all actually quite reasonable questions. So I asked it to give it the answers. Again, here are the questions and here are its answers. I said, please give answers to each of these questions. It did. These are the correct answers. Very interesting, right? So in this case, it read a lesson. It generated test questions along with answers. That's a pretty interesting behavior. Is it perfect? No. Does it make mistakes? Yes. Is this impressive? Yes. Is there a future here? I think so. So those are my experiments with GPT, ChatGPT. By the way, last night when I was madly putting together my final version of the slides, I got the message from Microsoft saying, you're in. So now I'm on the list of people who can use the search. You know, Bing has now got ChatGPT embedded. You have to sign up to get on the list and you have to wait a little bit. But as of last night, I was torn between finishing my talk, playing with Bing. You can judge which I spent time on. Okay, so now what if we put together this stuff that we've been talking about? It seems to me, if we put just what we've been talking about so far together, we could have a continuously improving, never-ending learning, teaching environment with the following kind of behavior. Continuously generating new content, meaning new questions and new hints. And that can be done partly by AI. You saw the ChatGPT examples. That'll take some more development. It's not ready for prime time, but if we're talking about 2023, this seems very plausible. Partly it'll be by teachers. We've got a system now where if you think you've got a good hint, you can just give it the CK12. You can just give that hint. We'll put it alongside the other competing hints. We'll empirically determine whether your hint outperforms the best one we've got so far. And if so, we'll use your hint. So we should be able to entice teachers who think they know how to provide hints to drop in their hints, and we'll report back to you in a few weeks how your hint performs compared to the others. So I think a system where we're continuously getting new content, new hints, new questions, maybe new lesson content too, contributed by the AI, by the teachers, and oh, by the way, by the students. The students also ask on CK12, there's a chatbot. Students answer chatbot questions, and CK12 has a list of the most commonly asked questions from students. Those could also be part of the never-ending generation of new questions and so forth. And as we saw, that could be customized automatically, in some cases, to the interests of the student. So that's a continuous generation, but also we can assess empirically which of those teaching actions work best. We can track each student's knowledge state, not perfectly, but this is also going to get better and better over the decade. So if you put that all together and bring in conversational interactions with ChatGPT-like systems, I think this is a kind of picture of what we might really look forward to if we work hard and we're lucky in the coming years. I think this is a good vision to aspire to. Okay, so let me move on to multimodal perception. I said there were three technologies that I thought were going to be most important in influencing the future for education systems. You can see why I thought of machine learning and natural language. The reason I think multimodal perception will be important is that right now, the systems I've talked to up to this point that I've talked about have all been on the screen. There's students doing stuff on the screen with computers, but so much of learning takes place off the screen. And so the ability of AI systems to observe what's going on in the real world, far field speech recognition, computer vision, face tracking, takes us from the previous period of history where computers were basically unable to see or hear what was going on unless it went through the screen, into a world where they can see and hear what's going on and converse and speak to it. So that's got to be an important part of what happens over the next decade. For this, I just want to show you a couple of videos to show you what kind of, here's an example of a face tracking system provided by a couple of my faculty colleagues at CMU. I don't know if we can hear this.
I'm fine.
Okay, what's
Sure.
okay? I think if I got into microphone feedback issues there, but what's going on here is this person is being face tracked and speaking, and the system is trying to automatically gauge the valence and the intensity of their emotional state. This is an early piece of work, but this kind of work of recognizing human motivational and emotional states, you could imagine, could be very important. It's very important to human teachers. It's very important to human lecturers. As I look at you all, I can, either see you reacting or not reacting. I adjust accordingly. Computers today don't do that very much, but that could change with this kind of technology. Okay, so then in this case, you could think of it as just a way of increasing the observability of the student's state, not just their knowledge state, but their motivational and emotional state. And of course, all of those play a role in assessing what teaching action you want to do next. Maybe it's time for the student to take a break. It also leads to systems like this, which I can only show you if we really have the sound working. So I'm going to, do you think the sound worked on that last? Do this. This could be bad because I'm on mute, but I'm still going to. Okay, here we go.
Yeah, that's right. So what do you think you should do next?
Why don't we try now? No, no.
No, that's not quite
Okay, all right, here we are.
Yeah, I think that's right. So what's the next? Such a good speech. Okay, let's go to the next one we're having homework.
Okay, what's going on is he's working on the screen up there in the right corner, but there's also a camera and microphone conversation with a virtual agent. And what you see is
谷歌直接拒绝中国号码，不 OpenAI 就是 ChatGPT 那个，他直接拒绝。
Whoever is talking online, you will turn off your please mute. We're hearing that one.
Okay. All right. The point of that was simple. Here's the prototype example, again, contributed by Justine Cassell and her collaborators, that shows a student working both on the screen, but also off-screen communication going on. So this little box up in the right, where the student was solving this algebra problem step by step. But then in addition, she was looking at a screen where there was a virtual agent who was having a conversation with her and who was looking at her and listening to her voice so that they were having a conversation about the solution to the problem. One of Justine's particular interest here is whether these kind of virtual agents can actually be useful, and whether students will feel any kind of sense of rapport with those kind of agents. But I think this video shows that in this case, this girl actually got engaged enough with the person with the virtual agent to say that she was enjoying interacting, working together. So I think, again, these are very early days, but it's an example of the kind of ways in which multimodal perception and communication might seriously shift the way we think of how computers can help education. I have one more video, but it has the same audio problem. So maybe I won't show that one. Let me finish up this way, because I want to have plenty of time for discussion too. Okay, so I really focus primarily here on how AI agents and students could interact, and how machine learning, natural language, and multimodal perception could be used to improve education. But in fact, of course, there are other parts of the equation. There's the human instructor. There are also the parents in many cases. but let's say consider the human instructor. And so at minimum, there's a triangle of computer agent, student, and human instructor that we want to consider. In fact, at Squirrel AI, when Richard and I were doing our work together there, the standard setting was that students would come in, maybe 6 or 10 students sitting in a room, each with a computer, but there was also a human teacher in the room who was observing and dropping in on different students as needed to help out. And that kind of setting, I think, makes a lot of sense. Again, it's kind of that setting I think of as one teacher with as many teaching assistants that happen to be computer teaching assistants as there are students. So the student gets both one-on-one help, but also the human teacher help is available. So if we think of that triangle of computer, student, and teacher, it's interesting to consider, well, how can computers play a role, say, in the student-human interactions? If the student is working on a computer and some problems, they get stuck, the teacher come over to help. Multimodal perception can allow the computer to observe the interactions between the student and the instructor. Maybe listen in on that conversation. What hint did the teacher give to the student? Maybe we can capture that hint and add it to the list of hints that we're continuously empirically evaluating. Maybe a little bit more ambitious, the system could join in on the conversation if it could think of things to be helpful. I think Sydney may have more to say about this. What about the human instructor and AI agent? What kind of interactions make sense there? There, I think, very interesting possibilities. The AI can help the human teacher, for example, as it did in the Squirrel AI system, by calling the human over when a student does need help. And also maybe by summarizing the empirically learned lessons about what kind of hints and what kind of guidance, teaching actions really are most helpful to students. But the human can also help the AI by teaching their best practices to the AI agent, either deliberately by saying, here's another question you should add to your list, here's another hint, or maybe less directly, just by working with students and letting the computer observe that work and that conversation and what the teacher is really doing. So I like this way of thinking about education as a kind of triangle in this sense. And so I'm going to leave you with that. I'm going to skip that last video because it's another troublemaking sound video, and just leave you with a take-home message. If you get anything out of this talk, number one, you should realize we live in a really special point in history. Nobody has ever had the opportunity that we as a research community have to put together AI in a way that can truly help education. The pieces that are in place now have never been in place. And so there are many, many opportunities here. I talked about technology, but it's going to require more than technology. It's going to require addressing things like privacy issues. There's a growing set of regulations and constraints on sharing student data, equity, teaching standards, standards for capturing data and sharing data. Right now, we have a very stovepiped industry, I think, where many companies charge for their services and do not share data with one another. But again, if you go back to our lesson about what machine learning can do, it seems to me that if we had a national worldwide asset of educational data, we might be able to actually make advances that no one of us could make alone. So with that, let me just thank you for your attention. And I left plenty of time for your own thoughts. I really am interested in what you all think about as the important goals we should aspire to in the coming years and what are some of the issues that we're going to have to face. Thank you.
So, yeah, we have actually more than 70 on the internet. We have
Richard, you have to speak into the microphone.
oh, yeah, so.
Can you hear me? Okay, yeah. So we have, I think the majority of the participants actually are coming from the internet. And we also have about, 30, 40 people here. And I would like to kind of like divide a little bit in terms of the Q&A. I think because of, for any of the speaker who are here, the majority of the Q&A will be actually here, right? So because this is a lot easier in terms of the interaction and communication. And later on, when we have those more virtual ones, and then we'll kind of shift the focus back to the online audience. So that is currently how we're going to, plan to do the Q&A. So for any people who are actually want to ask questions locally, please, we have and then you can also take my microphone. So please go ahead. And first, I want you to do a quick, just who you are, and then don't ask the question more than 30 seconds. Okay.
Hi, everybody. I'm Tiffany Barnes. I'm from North Carolina State University. Thank you for a really great talk. As I was listening to you talk, I just wondered, what's the incentive for all the humans in your triangle to get involved in that? So, now that we have more AI capability, more data, people are learning about AI and wondering, what am I going to get out of this? Why should a teacher teach an AI how to teach better? Why should the student, only work with an AI? Why should they let their data be used by AI that is going to benefit maybe someone else down the line, maybe not them? Thanks.
Let me make sure I understand the question. Is it fair to summarize the question as what's the role of teachers here?
No, I mean, how about all the humans? Why should the humans trust us to do a good job with the machine learning to benefit the students, to benefit the teachers? Why wouldn't people just say, why should I share all of my data? Why should I share all my teaching expertise? Why should I share all my materials? What am I going to get? What are people going to get out of this triangle?
Right. What are people going to get out of the triangle? That's a good way to summarize the question. I think what we're going to get is better education for our kids. Would I do it for better education for my kids? Yep.
Okay, yeah, university professors, but why should the kids give their data? Why should the K-12 teachers give their materials? Why should they teach the AI how to teach better? They're going to lose their jobs. This is like a big part of the conversation nationally about AI.
Okay, good. Now I get it. So I honestly believe teachers are not going to lose their jobs due to this. I think what's going to happen, just like I think doctors are not going to lose their jobs from AI, what's going to happen is the teachers are going to get computer-based teaching assistants that they can give to each student. So just think, for example, about homeworks, which is one way that I think will actually make the transition from here to the future. I think homeworks are going to be the pathway. So right now, teachers make up homeworks. They come in, they grade them. Computers, of course, can grade them if we put them online. But once we put the homeworks online, we notice that we're no longer locked into the idea that every student gets the same 10 questions. We're not even locked into the idea that we have to decide what the 10 questions per student are in advance. It could be that we could design an online homework assignment which has the property that if you get the first question wrong, you're going to get a different second question. But first, you're going to get to see a video or a brush up of the material that you didn't understand on question one. So I think that's an example of students are working at home. Teachers aren't going to go to each student's home. Can't do that. But we could send a teaching assistant home with each student. And that's where I think the computer might have its first most important use. In the classroom, so much of learning, honestly, still depends on motivation, understanding. The biggest single problem with online education is dropout. Many students never complete, and the reason is it's really hard to stay motivated if it's some darn computer you're interacting with, whereas teachers know how to engage. So my picture is teachers are going to be essential to education forever, but what'll change is right now the teachers cannot afford to give continuous one-on-one attention to each student. If they had a computer-based teaching assistant per student to collaborate with, they'll be able to do better. So that's my picture. We'll see. The future will tell.
Thank you. Hi, I'm Cassie, and I'm a PhD from the University of Sheffield in the UK. Thank you very much for the inspiring talk. And I especially like your points about the importance of teachers in the class. My question is, I've actually deployed AI in the real classroom, and I built conversational agents, but I've embraced lots of challenges. For example, the first challenge is about the acceptance of the new technology by students. So students, as you've already discussed, that students have some concerns about the AI or the privacy issues, the ethic issues. In the beginning, they're not very likely to use the new technology. But then I come up with a solution about make them accept AI, which is integrates AI with gamification. And gamification can also improve their motivation and engagement in the classroom. And also there are lots of actually errors generated by AI, and I'm using gamification to explain all the errors to make them accepted. But there is also a, sorry. Oh, yes, sure. Yeah, sorry. So my question is, how to ensure the accuracy of the responses generated by AI, and how to improve its performances for higher cognitive levels questions. Thank you.
Yeah, I think you raise a really good point. These AI systems are not perfect. They make mistakes. And as long as that's happening, we need to do one of two things. We need to either wait for them to get smarter, or we need to find ways to incorporate them so that it's fail soft, right? So, for example, suppose we ask GPT to generate a question on some material, and it generates a crazy question with wrong answer. We shouldn't just take that and deploy it. What we should do is we should run that question and the purported answer by a human before we put it into the system. So that still might be a good way to generate material. We might get ideas we hadn't thought of, but if to the degree that an error could occur, we still need a human in the loop. So I think that's the way it's going to be for a while.
Thank you.
Thanks.
Hello, I'm Aparna Bardey from Montclair State University in New Jersey. First of all, thank you for the excellent talk. And I like the three areas that you presented: machine learning, and then NLP, and then multimodal. My question is actually related to ChatGPT. So the hints that it provided were a little too long, I thought. And so do you have any thoughts on that, on whether that calls for some improvement? Because if I were a human teacher, I would definitely give a much shorter hint. The other question is, I think what everybody has right now, that's the ChatGPT controversy about whether it should be allowed on college campuses, because students are using it for a lot of things. And that's in a way getting in the way of creative thinking, so to speak. They use it even to write essays and all kinds of things. So what are your thoughts on that?
Yeah, that's great. So the first question, were the hints too blunt? Maybe. What I'd love to do is train a version of ChatGPT for hint giving. So the way ChatGPT was trained is first there was a large language model, GPT, which was trained with unsupervised data, just basically training it to predict the next word in every text sequence. But then they did a second pass where they used reinforcement learning, and they trained it with human supervised data, where humans said, were given, for example, here's a question and the answer from GPT, do you like it or not? And so they get a lot of human labeled data. And that's what actually made the quantum jump from how good GPT was to how good ChatGPT is. I think if we had human labeled data targeted toward hint giving, we might be able to do something pretty interesting. So that was the first. Second one, should GPT or ChatGPT be allowed on college campuses? Who knows? Carnegie Mellon, my university, has a team of very erudite faculty considering that question right now. My opinion is it reminds me a lot of the discussions around calculators in the 1980s. Should we allow calculators on college campuses? The answer 40 years later turned out to be, we should be teaching people how to use calculators. And maybe 40 years from now, we'll just assume we should be teaching people to use AI tools. It could be a rough road in between now and then.
Okay. Okay. Thank you very much. Thank you for the excellent talk again.
Thanks.
One question. So, I know thinking originally was modeled from from Tennessee 11. The work, I think you have very good feedback. So let's come up with that a little bit, and we'll cut off before.
Okay, thank you very much for your talk today. My name is Ye Wang from National University of Singapore, and I came across the world to ask the question. So in fact, this question is related to the first question. Frankly, as computer scientists, we develop the systems, right? AI technologies. So it's kind of very difficult to motivate real teachers, and they have busy schedules. Why they should actually support us and by give us their best practice and materials and so on. What's the incentive to motivate them to participate?
Yeah, that's good. I know educators whose incentive is to educate students and who would do it the best way they can find it. But I understand there's this concern about skills and having a good job and being remunerated for that. I think that the bottom line is education can be improved by introducing computers, and the solution will be a combination of social as well as technical advances. And I think education can look to medicine as an example that's a little bit of education. So for a number of years, we've had computer tools that in different areas of medicine can do very good job, more thorough job than doctors, for example. And you could argue whether doctors are better radiologists or computers, but what you can't argue is that a doctor using a computer, that's better than a doctor not using a computer. And it took medicine many years to get to that point. And still medicine, I was at a meeting recently at the National Academy of Medicine, asking why isn't AI more widespread in medicine? Everybody agreed. The answer is not technical at all. We have the algorithms that can be trained to do better diagnosis. We have the wrong incentive structure in the medical system so that doctors aren't motivated to use the tools, and hospitals are not motivated to share their data. In fact, they're regulated to not share their data. So I think how we get from here to there will be a social as well as a technical problem. And I think we should look at some historical cases like medicine to see what we should expect and what we need to do to make it fair to everybody involved.
Thank you. Hey, thank you for the good talk. Thank you, great one. So my name is Yang, and I'm from NC State University, working in the area of AI for computer science education. So my question would be like from the AI bias perspective, like how should we address the AI bias issue, especially considering that the feedback or the hints we give to the students are sort of like they are from younger generation. Maybe they are more easily to be impacted by these kind of issues if we have something similar happens with some sort of previous models, such as like, you know, Google previously got some issues on AI biases on the diversity or inclusion things, right? So I think this is one good thing to address. Would you like to share your perspectives? Thank you.
I think you raise a good point. I don't have the answer to the AI bias issue, but I do think, again, it comes to one of the earlier questions, which is, given that AI is not perfect, how do we take advantage of it? And I think having a human in the loop is part of the answer to that. And that also goes a long way for treating the bias thing. So, for example, you have AI rephrase the question in a way that'll be more interesting to a 7th grade girl or a 11th grade boy. You can imagine various biases playing a role there. You could imagine that having a human in the loop could be one way to make sure those biases don't get automatically transmitted. But I don't have the answer either.
Sure.
I do know that, you know, that the GPT people and the Microsoft people are very interested in how to depress the bias problem.
Sure, thank you. I guess maybe educators should also think about their own ways to address from a curriculum or pedagogical side to just push this move forward. Thank you.
Thanks.
Hi. First of all, thank you for a wonderful presentation. I'm Anup Sakya from University of Memphis, originally from Nepal. So my question is, you discussed that one-on-one instruction given by the human tutor is the best form of teaching. So for computer tutors, like there can be many instances, like the students can cheat the system. So how can you make sure that the students are actually learning and not just like cheating?
Great. Yes, the cheating question. That's another killer question for online. Actually, ChatGPT has really raised the importance of the cheating question. I don't have an answer to that, but you know, as an educator myself, honestly, I'm thinking in the future more oral exams. You can and fewer. You can cheat all you want on the homework. I don't care. Your grade's going to depend on your oral exam with me at the end. So I think we're going to see a shift in that direction. But cheating is a really big deal, and I think we set up the right incentive structures for students, like they're going to have to pass the oral exam with me. And then I tell them, you can cheat all you want on the homework. I really don't care. Students are smart in the end. With the right incentives, I think they'll make the right choices. But I hope that's true.
Thank you.
All right.
Yeah, I think we will, again, thank you to the for